Hey everybody! In the previous video, we covered the basics of navigating the Godot 4 editor and environment. Now it's time to acquaint ourselves with GDScript, which serves as the Godot engine's native programming language. Visual tools can be incredibly helpful in game development, but they have limitations when it comes to implementing complex game logic. This is where scripting becomes essential. In Godot, you can assign custom scripts to individual nodes, which are executed when the respective nodes enter the node tree. This capability enables dynamic node activation, allowing for greater control over the game flow. Consider the system of enemies in our game. Each enemy object is associated with a script that controls its behavior independently. By utilizing custom scripts, you can create enemies with unique characteristics and behaviors, making your game more flexible and scalable. It's worth mentioning that Godot allows developers to mix and match scripting languages within a single project, including options like C# and GDScript. However, based on personal experience, I found GDScript to be extremely user-friendly and convenient, which led me to exclusively use GDScript throughout the development of my game. I would like to add that this video won't delve into every detail of GDScript's extensive feature set and internal functions available for game development. For a comprehensive reference, the online documentation is your go-to source, and it's worth noting that the Godot developers and community have diligently maintained and updated it. I included a link to the documentation in the video description. Let's open our sample project and explain the GDScript fundamentals on a real code. Okay, here it is. So, what are the key characteristics of GDScript that we utilized in our game's code? Let's start with something that doesn't affect the script logic at all, but can be very useful for the code readability. That something is comments. Everything after this hash sign is considered a comment, and the engine ignores it. It is also helpful if we want to temporarily disable one or more lines in the code for testing purposes. There is a nice trick I can show you. If you need, for instance, to comment out multiple lines, you simply select them and press Ctrl K or Command K on Mac, and voila, all these lines have been commented out. You can use the same functionality to uncomment them and get to the previous state. You have probably noticed that certain lines are pushed to the right side more than the others. That's because GDScript uses an indentation-based syntax, which means that instead of curly brackets that we can see in some other languages, the logical blocks must be indented by tabs. Take a look at the process function, for instance. We can observe that blocks that belong to the particular if branch are indented to the right, so it's easily recognizable which part of the code would be executed if this condition is fulfilled. It is forked even more down here, where you have another if condition. Let's get back to the top of the script and explain the lines you can see there. The initial line with the keyword extends denotes the base class. If you are unfamiliar with the concept of classes, you can think of them as structures that group together properties, variables, and functions that share common characteristics and are associated with a specific node. Every script is a class, and every class inherits from a base class. If the keyword extend is omitted, it inherits from a ref counted by default. I will describe specific classes like ref counted, object, variant, etc. in the following videos. So, what's the point of the base class? The answer is the inheritance. Once you define the base class, its properties and functions are available in your script as well. In our script, we extend Node3D, which provides us with access to 3D transform functions. If we like, we can change the position, rotation, scale, and similar properties from the code. We don't do it in this particular script, but let me show you better examples. For example, if I switch to an enemy object, it extends area 3D, which gives us, among other things, the area entered signal. If we switch to the node signals panel, we can see that all these signals are defined only for the area 3D class. If we extend the enemy from another class, they wouldn't be available. Or another good example is the player class, which extends character body 3D. This is a special class designed to move the main object in the game, usually controlled by the player, and it includes methods like, for example, move and slide, which is a complex method that controls the player's object movement and also its interaction with obstacles, sliding across them, etc. In the enemy GDScript, you might have noticed a new keyword class name. While this feature is not mandatory, defining the class name provides several advantages. For instance, a notable benefit in our game was in determining whether a destroyed object was an enemy, thus enabling the spawning of a power-up. Let me find that particular code. I think it was in Game Manager. Yeah, exactly here in Create Explosion. In future iterations of our game, we may decide to introduce various types of objects, but it's crucial to ensure that only the enemies have the ability to spawn power-ups when they are destroyed. Checking the class type by this operator is we use to control this outcome. Okay, let's get back to the main script, and we reach the section of variables. Variables in GDScript are essential for storing and manipulating data within scripts. Godot provides the flexibility to use either dynamic or static typing, or even a combination of both, depending on your needs. Here are a few examples to illustrate. The variable threat is defined with a concrete class, the threat, so it's statically typed, and only a threat class instance can be assigned to it. If I scroll down, it should happen somewhere in the process. Yeah, here it is. Let's see what happens if I try to assign, for example, a vector. Vector 3 and 0. And Godot displayed an error. Value of the type vector 3 cannot be assigned to a variable of type threat. Exactly. Let me just revert to the previous state. Okay. On the other hand, the other variables are declared dynamically, which means that they can contain any value. When it comes to static and dynamic typing, there is no definitive rule dictating which approach is superior. Each method has its own advantages and disadvantages, and the choice between them depends on the specific requirements and preferences of a project. It's important to mention that the variables, as we declare them, are unique for every instance of the particular class. The main script isn't the best example to explain that, because we use the main scene only once in the whole project. But let's take a look at the enemy class. Here. As we know, the game spawns many instances of enemies to attack the player's ship, and each enemy object has its own version of the life cycle, which means that they can individually and independently explode, change their behavior, or spawn power-up objects. Since Godot 4.1, GDScript supports static variables as well. When such a variable is declared, it would exist only once for all instances of the class, so it can be used for something that should be shared across all instances. It can be defined by using the prefix static. like this. Okay, let's get back. By the way, what is this already keyword before the variable declaration and starting with an @ sign? It is an annotation that instructs Godot to evaluate the value of this variable when the node enters the node tree, not immediately when the particular class instance is initialized. Effectively, it means wait until everything is ready, because certain nodes we use in the script, for example the player, have their own logic to prepare the internal structure, so if we don't wait for them, the game could produce various errors. There is also a useful trick to generate these declarations without the need to type everything manually. Let me demonstrate on Debris Light 3D. If you simply drag this node to the code and release, you will insert only the node reference. However, if you do the same but hold the Control key and release the mouse, voila, the whole already declaration appears here. Very nice. Just like variables, constants also exist in GDScript. They define values that remain unchanged throughout the execution of a script or project. Constants provide a way to assign fixed values to variables that cannot be modified during runtime. And just like variables, you can use static or dynamic typing to declare a constant. To see an example, let me switch to the Script Options Manager. And OK. Where we declare the path to store the game options as a constant string, because we don't expect it to ever change. During our game creation, we utilized Godot's built-in types as well, especially vectors. The vector types prove invaluable in various scenarios, particularly when dealing with 3D transformations. Additionally, we leverage these types within our level definition structure to precisely specify the behavior of the enemies. Let me show you a few examples. I think it would be somewhere here in the enemy class and the life cycle. So for instance, we call the function translate, which takes the vector3 parameter to set the initial coordinates of the enemy, and then we scale it up or down using a similar vector. If we find the level definition here in tutorial 3D, we should see a lot of vectors here. For example, this one for coordinates, another one for direction, and so on. Another important type is an array. They are an essential data structure for storing and manipulating collections of elements. An array is an ordered collection of values, where each value is identified by an index. Let me demonstrate several use cases in our project. I switch back to the enemy class, and you can see that we declare the variable weapons as an empty array, just brackets. If I switch to Sound Manager, there is another array but with values, so it is declared as non-empty. Let me find the player's class, here it is, where we can see the method for adding new elements to the array, weapons.append. And finally, if I switch to Control button, which we use for key mapping redefinition, we access the array element by index here. 0 means the first index of the array. Let's proceed with dictionaries. Dictionaries are data structures that store key value pairs. They are similar to associative arrays or maps in other programming languages. Dictionaries in GDScript are mutable, meaning you can add, remove, or modify key value pairs dynamically. I think we have a good example here in the utils class, where we detect all materials from the selected scene, and we start with an empty dictionary, just curly brackets, and once a material is found, we assign it to the array with the key derived from the material's ID and the material itself as a value. Or another good example is in our level class, which is full of dictionaries. We can see it here in the definition of the asteroid wave, for example. The array starts here and keys can be seen here in the yellow font, and the values are after the colon. And finally, let's say a few words about functions. Functions are blocks of code that perform specific tasks. They allow you to organize your code into reusable chunks, making it easier to write, read, and maintain. Furthermore, functions play a crucial role in handling the game lifecycle by allowing you to override node-level functions such as ready, or process, or input, and many more. By overriding these functions, you can customize the behavior of your game objects and respond to specific events or conditions during different stages of the game. In our project, we declared all functions dynamically, just like the rest of the code. Let me show you how a statically typed function would look. So this one looks pretty simple. Let me just change it. So instead of having a generic argument, just a name node, we will make sure that it is the type variant, and the return value is bool, which is equivalent to boolean in other languages. Now the function is typed statically. Alright, I believe we discussed some GDScript fundamentals, and hopefully this knowledge will assist you when analyzing code in other projects and tutorials. There are additional aspects of the language that we haven't covered yet, such as operators, conditions, loops, and more. I anticipate that we'll delve into these topics in our next session, where we'll also explain the Godot game lifecycle and how we can use it to manage game events effectively. See you in the next video.